Welcome back, guys. The last video about solving these equations, and it's a topic that generally people don't really like a lot. They don't like math, and math people do like stuff like this. And we're going to talk about solving literal equations. And an equation that involves several variables is called a formula. Generally, that's what most people will call it, just a formula. It's also called a literal equation. And what happens is you're not solving it for just a single, well, you are solving for a single variable, but you're not going to have a variable in just a number. You're going to isolate a variable. So a lot of times what they'll say is solve for the specified variable. And I will mention this too while we're talking about this. And I mean this. You cannot get lackadaisical with your notations and change capital letters to lower cases. I see it all the time. And you'll see it in these, let's see if I see any in here. Yes, here's an example of it. In formulas, a lot of times a cap letter means something totally different than a lowercase. And you can't interchangeably just sometimes capitalize, sometimes you don't. When you're working with equations, you need to keep the variables written the way they're intended, well, the way they were written to start with. The intent of the person that wrote the formula would be compromised if you start just assigning capital letters, and then it's just a bad habit, and just don't do it, okay? All right, so let's get to work and solve a couple of these. We're going to use our properties that we talked about. And as you can see, example 1 says solve 9 equals g f, and we're solving it for f. All right, so let's throw up this tablet here. So we're going to solve 9 equals g f for f. So if it said solving for a specified variable, that's what they mean. They're specifying that we solve for f, because there's two variables here, so you have to be specific. Can't just say solve. That would not make sense. Okay, now the first thing I want you to realize here is the relationship between g and s is understood to be multiplication, right? That's actually what's happening there. And you can look at this two different ways. You could look at it like, since you're solving for f, the coefficient of f is g, and then multiply by the reciprocal of g. Or you could say, well, usually if I was solving something like this, let's throw this over here. What if I had 9 equals 3f? You wouldn't have to think twice about that. You'd say divide by 3, man, that's how it's done. Well, why not divide by g? Because remember, these represent numbers. We don't know what number g is, but it doesn't really matter. We know if he's the coefficient of f, we need to divide by g. So that's the step we'll have to take. So what we'll have to do here is divide both sides by g. Now remember, we got to do both sides if we do anything. Otherwise, we don't preserve that condition of equality. So we find that 9 over g is f. And that's done. All right, so that's how you solve that one. So one step. 9 over g is f. Okay, let's go to example 2 and see what we got to do here. I want to get all these into one video because they're like 1-2 step. They're not real complicated. We got negative 7 plus r is q. We're solving for r. This one right here is a one step as well. And it says negative 7 plus r is q, and solve this thing for r. I don't know, I got goofy on that r just now. All right, so listen, if you got a negative r here, negative 7 and plus r, the only thing stopping r from being isolated is this number. And we don't need to divide because the relationship between the two things is addition. So this would be one of those cases where you want to do the additive inverse. Big words for saying just move 7 to the other side. Do the opposite sign. Plus 7. That's a negative 7. So we're going to add 7. All right, now you're going to have people who don't know how to combine this q and this 7. Right, because this is a 0 now. So we just bring r down. So that guy's alone now, like it's supposed to be. So what's the relationship between q and 7? It's added together. That's q plus 7. They don't combine. You can't do anything with it. Leave it alone. It's just q plus 7. It's not 7q. It doesn't say to multiply. It's not 7 divided by q because we added 7 to get that to be a 0, right? We need negative 7 to be a 0. We have to add to it. All right. So there's our second one. I'm going to clear it out, and we'll go to the next one. third. Oh, this one's kind of cute. This one could give some folks some grief. Let's see here. Let's write it down. So we're gonna solve a over 4 and that's equal to lowercase q minus cap q. And they're telling me to solve for little a. Okay. Now, this is one of those cases where you want to clear your fractions, right? There's only one fraction that we're worried about here, and it's a over 4. So I'm telling you the easiest way to go at this is LCD is 4, clear your fractions. But what the problem might be is you're like, how am I going to get a out of this numerator? I mean, can I subtract 4? No, that won't work. A over 4 minus 4 is going. That's not going to work. So the only way to get him out of there is by multiplication, because remember, if you multiply 1/4, because that's essentially what that is, a times 1/4, by 4, you get 1. And the coefficient of a will be 1 if we do that. So I'm going to show the steps here. We have 4 times a over 4 is equal to 4 times q minus q. Gone, gone. So a equals 4 times q minus q. Is that done? Yeah, that is done. Some people might distribute that 4 in there and have 4 lowercase or 4q minus 4 cap q, but I would consider that done enough. I don't think anybody is going to have too much trouble with that. Now, if you get in there and Delta Math challenges that and wants it distributed, then you'll have to, because that program may be running on some algorithm that requires that. Okay, so but I don't think it will. Let's see what's next. We've got to solve one last equation here. So we're going to solve this equation, which has 1, 2, 3, 4 variables, and we're going to solve it for the cap D right here. All right. That means we want to get cap D isolated on one side by itself. Who's in the way? The first part of the question. Well, n's being added to this expression. And then finally, someone's cubing an m. M cubed is being multiplied to D, which really means eventually we're going to need a division, because that's multiplication. We're going to need a subtraction, because that's addition. We're undoing this stuff, right? So that's another way to look at it. So if I have D m cubed plus n, and that's equal to r, and I'm solving for cap D, right? I don't know why I called it cap D. There's only one D there. All right, so the first order of business, compare this to solving 2x plus 1 is 7. You would not start by dividing or anything like that. You'd subtract this away, because remember, you're targeting this, right? That's your target. That term, you'd say minus 1, minus 1. And then you'd have your 2x, and that would be equal to your 6, right? We're going to do the same thing here. This guy's in the way by addition. He's going to be our first target. So add the negative of it. I don't care what value n is. I know it's negative opposite, or it's opposite. It'll give me 0 right here, right? So now I have d m cubed equals. I'm going to call it r minus n. It's the same as r plus negative n, same as negative n plus r. I tend to like the negative in between them, so that's the way my order works. All right, now compare it back to this equation. I hope that made sense. We just moved it over. Now, in solving this, our final step would be, we know that's multiplication, we would divide. Right? That's how we would do it. Well, why not divide here? I don't know what m cubed is. It's some value, but there's no reason we can't divide by m cubed. There's no rule saying, hey, I don't know, if it's an m, we can't divide anymore. There are no rules like that. It's a real number, so we're just going to divide by m cubed. Right? And now we'll have d equals, now he's alone, he's isolated, they're going to cancel, r minus n over m cubed. All right, so that's a quick lesson on literal equations. If you get in the weeds real deep with this stuff, let me know. We'll talk about it some more. I hope you found that helpful.